Detailing the mold with the Add Component wizard. First, we isolate the core plate and connected geometry by double-clicking on the folder structure under the MoldWorks Feature Manager tree. Now we use the standard component folder to access the component groups to select a specific component, in this case a cap screw. MoldWorks opens a property manager with two tabs. In the first tab we select a start place for the component and select, or in this case create, a positioning sketch using the small icon to open the SolidWorks sketcher. Notice that we get an instantaneous accurate OpenGL display of the screws at each point, and that all the MoldWorks plates and inserts are temporarily displayed as transparent. On exiting the sketch, the Property Manager appears with the second tab active. This tab describes the component parameters. For the screw, selecting the part to fix into the plate will automatically find the minimum distance screw whose length is sufficient to satisfy the active screw rule. Here it found the M6 screw, and of course the screws are duplicated to the second core instance. We change the screw diameter to 10. Next, we add a core pin, Ejector, to knock out the bosses in the core inserts. Since we are using an ejector, MoldWorks assumes that the start face is at the top of the ejector plate. In this case, we want to use the static bottom clamping plate as the start face. Here we select a sketch indicating the center of the bosses. Now we select the top of the bosses as the length of the core pin. Notice that a bigger core pin, long enough to reach the point, has been displayed. Here we modify the diameter to approximately reflect the boss size. In order to fix the core pin into the plate, we add an offset at the bottom, while MoldWorks still makes sure that the top of the core pin remains at the same selected position. Next, we will add ejector sleeves around the core pin. The ejector plate has been selected by the software as the start face. Here we use the component selection to position the ejector sleeves and select the core pins. The sleeves are positioned around the core pins, with the inner diameter of the sleeve equal to the outer diameter of the core pins. This type of intelligence exists for many other suitable components as well, like springs, screws, interlocks, etc. Next, we give AUT as the length parameter, which will cause the ejector sleeves to look for the start of the plastic. Finally, we create a trim ejector. Here we give a point on the fly, opening the SolidWorks sketcher. We key in a diameter of 10 and choose the trim parameter. Toggling to AUT, we can see that the ejector reaches the first point of the plastic. Changing the length parameter back to trim now causes the ejector to pass through the plastic in order for the system to then trim it back after creation. Since the ejector will not be symmetrical, we will add a lock. The ejectors have an extra tab to add locks. There are 4 types of ejector locks. In this case, we are going to create a 2-sides lock. The ejector is trimmed and the locks are created. Now we show some views of the results. Here we can see the ejector lock.